3I Atlas is not just another comet.
As of now, I would rank it as 4, given all the anomalies that I mentioned, and the chance of that happening is 1 in 500 or so.
Do we have the technology and the ability to intercept and deal with, in the future, anything alien?
Officially, no.
3I Atlas challenges everything we thought we knew, and whatever it is, we may never see it again. It all started on July 1st, when the Atlas survey system in Chile flagged a fast-moving object cutting across the sky, a dim, silent intruder entering from the direction of Sagittarius, near the dense, star-packed core of our galaxy. At first, it looked like another distant comet, a cold wanderer from the far edge of our solar system. But that theory didn't last long. As more telescopes locked onto the object, astronomers quickly realized it was moving far too fast to be bound by the sun. Its trajectory was hyperbolic, an open path, inbound, from deep space, destined to swing past and never return. But the speed wasn't what raised eyebrows, it was the precision. Most interstellar objects, like Oumuamua or Borisov, arrive on steep, irregular paths, crossing through the planetary system at odd angles. But this one was different. 3I Atlas approached on a trajectory just 5 degrees off the ecliptic, the flat plane where all major planets orbit. And as orbital models were refined, something even stranger became clear. The object wasn't just crossing the system at a convenient angle. It was set to pass near Venus, then Mars, and then Jupiter. In that exact order, a gravity assist sequence eerily similar to the ones we designed for spacecraft. That kind of alignment isn't impossible, but it's not what you expect from a random interstellar rock. In fact, Avi Loeb, the Harvard astrophysicist known for challenging conventions, publicly estimated the chance of such a sequence occurring by pure coincidence at roughly 1 in 20,000. It's a number that doesn't prove anything by itself, but it refuses to go away. Then came the size estimates, based on its brightness and assuming a dark, rocky surface. 3I Atlas could be up to 20 kilometers wide, making it by far the largest interstellar object we've ever observed. And yet, during its initial approach, there were no visible signs of typical cometary behavior. No jets of gas, no clear outgassing, just silence. The silence might still fall within the realm of coincidence. After all, the cosmos is vast, and probability has room to play. But for those paying close attention, something about 3I Atlas feels off. And unlike Oumuamua, which was gone before we could react, this time we have a window, a brief chance to observe an interstellar visitor, not after it's left, but as it moves through the heart of our system. And the closer we look, the less ordinary it seems. From the moment 3I Atlas's path was reconstructed, it became clear this wasn't just an object passing through. It was following a line, clean, calculated, and deeply improbable. Its retrograde orbit, cutting against the flow of planetary motion, was expected for something from deep space, but its low inclination, skimming just above the ecliptic, set it apart from every other known interstellar visitor. Most objects from other star systems approach at steep angles, diving in from above or below the solar plane. But 3I Atlas seems to glide along the same corridor we use to launch probes, a region of space that minimizes energy use and maximizes planetary assists. Coincidence? Perhaps. But each layer of alignment makes that explanation harder to defend. The flyby sequence, Venus, then Mars, then Jupiter, mirrors the same maneuvers used in mission planning for interplanetary spacecraft. In fact, if a human engineer had designed a trajectory to efficiently survey the inner solar system without stopping, it might look exactly like this. That doesn't prove artificiality, but it forces a more uncomfortable question. Why does a supposedly natural object move with the elegance of intent? Some scientists argue that these planetary encounters are a statistical fluke, an unlikely but possible result of gravitational chance. Others aren't so sure. Avi Loeb, continuing his advocacy for rigorous open-mindedness, has urged the scientific community to treat 3I Atlas as a pedagogical case, not because we have proof of alien technology, but because the pattern of anomalies demands deeper scrutiny. In his view, we lose nothing by asking the harder questions, and we may gain everything if we find something we weren't supposed to see. That challenge becomes even more urgent when we consider the timing. As 3I Atlas races toward its closest approach to the Sun, it will pass behind the solar disk from Earth's perspective, entering a window of observational blackout at the exact moment when cometary activity is expected to peak. Ground-based telescopes won't be able to track it. Hubble will be blinded. Even the James Webb Space Telescope will have to work around its pointing limitations to avoid damage. To some, that's just bad luck. To others, it borders on tactical, as if the object were designed to vanish at the moment of greatest scrutiny. And while that may sound like science fiction, the physics remains. A small adjustment, even just a few centimeters per second of acceleration, would be enough to subtly shift its trajectory over time. If 3I Atlas were equipped with any form of propulsion, even passive or ancient, that level of control would be more than plausible. Of course, there's no direct evidence of such a mechanism yet, but we know how to look. That's why Hubble and Webb are watching, dissecting its coma, capturing its light, hunting for chemical signatures that could betray its true nature. Because if this object is what it appears to be, natural, ancient, and purely inert, then it may still teach us more about the galaxy than any comet before it. But if it isn't, if the trajectory we're seeing is not random, but chosen, then we may be staring at something far older and far more deliberate than anything humanity has ever encountered. For weeks, telescopes across the world and above it have been locked onto 3I Atlas, trying to answer a question that's older than science itself. What exactly are we looking at? At first, the object was silent. No obvious jets, no tail, no visual cue that it was shedding material. Just a cold, massive core gliding through space. But as it moved closer to the Sun, that changed. The coma formed slowly, a faint, diffuse envelope of gas and dust. But its behavior wasn't entirely typical. In most comets, solar radiation pushes particles away from the Sun, forming tails that stretch into space like a banner caught in the wind. But part of 3I Atlas's dust stream seemed to bend toward the Sun, as if heavier grains were resisting the expected force. That alone suggested something unusual in the composition. Something dense, perhaps metallic, or at least larger than standard cometary dust. Then came the spectral data. From high-resolution instruments aboard the James Webb Space Telescope and Earth-based observatories like Gemini South, researchers began to assemble a chemical profile. And what they found was both familiar and unsettling. Water ice, carbon-rich dust, silicates, organic molecules, not unusual on their own. In fact, these are common in many comets. But these weren't fresh materials. They were ancient, possibly older than the Sun itself, preserved in a pristine state, as if sealed away in a deep freeze for 7 billion years. Some of these compounds showed minimal radiation damage, minimal thermal cycling, and spectral features that suggested they had never been close to a star until now. Even more strange was the mismatch between brightness and size. The coma was unusually luminous, yet the estimated nucleus remained smaller than expected for that level of activity. That led some scientists to propose an alternative. Maybe the surface isn't just reflective. Maybe it's unusually efficient at scattering light, perhaps due to a smooth texture or even an engineered shell. At this point, every new piece of data seemed to deepen the mystery rather than resolve it. The more we learned, the more contradictions appeared. Each signature, chemical, optical, dynamic, added another layer to a profile that simply didn't behave like the comets we know. And perhaps most disconcerting of all is the object's origin. Orbital reconstruction places its point of origin in the direction of the thick disk of the Milky Way, a region dense with ancient stars and primordial debris, far from the younger, brighter stellar nurseries where planets are born. That suggests 3I Atlas may have been traveling for billions of years before arriving here. It could be a fossil, a shard of galactic memory, unaltered since the beginning of time. Or it could be something else entirely, a fragment of design, a long-dead probe, a watcher awakened by starlight. No one is claiming certainty. No responsible scientist is shouting alien without proof. But more and more, the conversation is shifting, not toward belief, but toward possibility, because 3I Atlas is forcing us to confront the limits of our models. And in those limits, we find the shadows of something we don't yet understand. Soon, 3I Atlas will be gone. It will vanish behind the sun, hidden in glare, unreachable by even our most powerful telescopes. And when it emerges again, weeks later, quieter, colder, fainter, it will already be on its way out. A silent stranger, slipping back into the void from which it came. We'll be left with data, spectra, images, charts, all of it remarkable, and yet none of it conclusive. Because even with the best instruments ever built, we may never know whether this was a comet like no other, or something more deliberate. Something designed to pass close, but not too close. To show just enough, but never everything. Maybe it's just a coincidence. A natural relic from a distant system, following an improbable path through ours. But if it isn't, if the trajectory, the chemistry, the silence, if all of it points to something artificial, then 3I Atlas might be the first message we've ever received from a civilization long gone, or one that still watches quietly. A probe that doesn't communicate, doesn't land, doesn't wait. It just moves, and then disappears, like a ghost. And maybe that's the most unsettling part. Not the possibility that we were visited, but that we weren't the destination. Just a stop along the way. A waypoint in the dark. Whatever the truth is, this moment matters. Because 3I Atlas has done what few objects ever do. It forced us to question what we think we know, to widen the aperture of possibility, and to ask once again, are we really alone? We're just not paying attention. If you've watched this far, you're one of the few who's listening. So leave a signal. Subscribe to the cosmic unknown. And if this journey speaks to you, the mystery, the silence, the thrill of not knowing, consider becoming a member. We're building something just for you. Soon, we'll bring exclusive content for those who want to dive deeper and drift further. Because the sky isn't empty. It never was, and now we're finally beginning to see it.